All right, so this is going on page 35 when we're done. Okay, so we put functions together yesterday. We added, subtracted, multiplied, and divided. That's one way, or those are 4 ways to combine functions. We're going to look at another method to combine functions today called composition. Okay? If you compose something, if you compose a piece of music, you take notes, you put them together, you make them sound like beautiful music. If you're going to write an English composition, you put words together and you write a beautiful story or whatever. So you can compose a lot of things. When we're composing functions, we're putting them together. So composition, compose, and composite, and those are all the same word, just different versions of it. So if we have f of x and g of x, the composite function is defined as, remember notation is everything, this is f, this is a tiny little open circle, and then g of x. So that reads f of g of x. Yesterday we had something that looked similar, but it was a dot, and that meant that we multiplied. Okay, so they look very similar, but they are different. Another way to write this, and the way that I prefer, is f of g of x, like so. Okay? F of g of x. Okay? All right. So before I'm going to write something over here, and I don't want you to write this because I'm about to erase it. But if I said we want f of 3, okay, what would you do with this 3? Plug it in where x is, right? Because this 3 replaced x here. So it's going to replace x there, right? We're doing the exact same thing, but with functions. And this is not brand new, so we're going over the concept of it. And then we're going to work through some problems just because different algebraic and numeric things happen, and we're just going to kind of practice the math in there a little bit. All right, so f of g of x is the same thing as f of g of x. So that means I'm going to take g, and I'm going to substitute it in here where x is. So x squared minus 4 plus 7. Okay? And anytime you substitute in something with more than one term, you put parentheses around it. These aren't doing anything. So in the end, I have f of g of x is equal to x squared plus 3. Okay? Everybody okay with that? Good? All right. So then here we have g of f of x. And that means now I'm going to take f, and I'm going to put it into g. So this is equal to of x plus 7 squared minus 4. Right? Tell me what x plus 7 squared is not. X squared plus 49. So everybody tell me, x plus 7 squared is not what? Plus 49. Everybody say that now. X plus 7 squared is not what? Thank you. Okay, I would rather you not have a clue as to what to do than put x squared plus 49, because that tells me you don't have a clue what you're doing also. All right, so x plus 7 squared is the same as x plus 7 times x plus 7. And you can FOIL that, do your box method, whatever it is you do. But there's also a pattern to this. This is a perfect square trinomial. So here's the pattern. You square the first one, it's x squared. You multiply the two together, you get 7x, then you double it. That's 14x. Then you square 7, and you get 49. Then you subtract 4, because it was a minus 4. Yes? What did I do wrong? What did I put? Oh, thank you. Why did it take you so long? I'm proud of you. Y'all, goodness. See, I don't mind that my video makes me look stupid. I just want it to be right. I don't know. I'm making stuff up. There's no way there's a cube. Thank you so much for calling me out. This is totally x squared. No idea where I got the cube. Probably because I was thinking 3. I don't know. What did I say? Do you know what I said? I said cube too? Oh, I said squared and put a 3? Okay. I don't know. My brain and my hand don't always agree. All right. Am I good on B so far? Yes. Yes. Okay. So now this is g of f of x. That's equal to x squared plus 14x plus 45. Everybody okay so far? We understand the basic concept, right? What you're putting one into the other. All right. So let's move on to number 2. I have f of g of 2. So I'm going to rewrite this like every time just because I think that it makes more sense. You can see which of 2. Oh my God. Y'all, I didn't eat lunch. I think I don't have any protein going to my brain. Whew, there we go. F of g of x. It's example 2. Maybe that's where that came from. I don't know. So y'all going to have to really pay close attention today, apparently. I'm going to take g of x and put it in here. So I get 3 minus x over x plus 1. Right? So when I add and subtract fractions, what do I have to have? Common denominator. What would my common denominator be? X plus 1. Okay, so that means that this number has to be multiplied by x plus 1 over x plus 1. So that's 3 times x plus 1 over x plus 1 minus x over x plus 1. Now I have a common denominator. I'm never going to write that step again. Okay, I skipped that step yesterday. You should be at the point where you can not skip the step of getting the common denominator, but skip the step of writing them separately. Because what happens is, I know my common denominator is x plus 1, right? So I can say, all right, if it's x plus 1, this has to get multiplied by x plus 1 over x plus 1, like I just said. So this gives me 3 times x plus 1. Minus, and then this didn't have to get multiplied by anything, so it's just x. It's the exact same thing as combining these two, but you can skip that step so you're not writing so much. Okay? We good with that? So now I'm going to clean that up a little bit, and I'm going to get, in the numerator, I'm going to distribute that 3, so I'm going to get 3x plus 3 minus x over x plus 1. That gives me 2x plus 3 over x plus 1. Can I reduce that at all? Not legally, without making up math, so we don't want to do that. That is f of g of x. Okay. Questions do you have? The calculator doesn't help you there. Changing it to a decimal doesn't help you there. You have to know your basic fraction rules and be able to keep up with your math. Wasn't lying about that. All right. So then I have g of f of x. So I'm going to take f, substitute it into g. So in the numerator, I have 3 minus x over 3 minus x plus 1. So I have something in the numerator that matches the denominator. Can I cancel out this 3 minus x? No. Why not? Because I have 2 terms down here, right? If it was just 3 minus x over 3 minus x, absolutely, but that's not what's happening here. So instead, I'm going to have, in the numerator, I have 3 minus x. In the denominator, that would give me 4 minus x. Now, can I cancel the x's out? No. This is equal to g of f of x. Okay. Any questions at all? Again, the concept of composing the function hopefully is there, but because different things are kind of happen, I think these are all pretty good to work through. All right, let's look at 3. This is f of g of x. All right, and then that means I take this g of x, and it's going into f of x. So I have 9 minus 2 times 4x plus 1 cubed. This time it is cubed. Okay. Can I distribute that 2? No. Can I do 9 minus 2 and get 7? No. I have to take care of my exponents first, right? So I'm going to come over here. So that is the same thing as saying 4x plus 1 squared times 4x plus 1. Would you agree with that? Yes? Stop whispering. What is this going to be 16x squared plus 1? No. Okay, so if you have to go off to the side and FOIL or whatever, that's fine. But remember, we have a pattern. That pattern is that we square the first one, that's 16x squared. We multiply the two together, then double it, so that'll give me 8x. Then you square the last one, that's plus 1. Then I have to multiply that by 4x plus 1. Okay. Then here, I'm just going to distribute. I'm going to take 16x squared and multiply it by 4x. That's going to give me 64x to the what? Third. Then I'm going to do 16x squared times 1. That's plus 16x squared. Then I'll take 8x, multiply it by 4x, and that gives me 32x squared. And then 8x times 1 is 8x. Then 1 times 4x, and 1 times 1. What? Where? Because you have to cube things first. You would have to cube the 2 before you, like, it just doesn't work out that way. PEMDAS, yeah. Okay. Aunt Sally says it's not okay. Yeah. She's always right. Okay, everybody with me so far? Okay. All right. So now I'm going to come back over here and substitute this in while I clean. I mean, I can combine terms, but I'm going to combine terms while I substitute it in. So I've got 9 minus 2, then in my parentheses, so I've got just one x cubed term, so this is 64x cubed. Then I have 16x squared and 32x squared, that's 48x squared. Then I have 8x and 4x, that's 12x, and then plus 1. So now I can distribute my 2 after I've expanded that. And is that negative important there? Yes, because I'm actually distributing a negative 2. So this becomes 9 minus 128x cubed minus 96x squared minus 24x minus 1. Minus 2. Jeez. Okay, I'm not skipping lunch anymore. I just want to see if y'all are paying attention. It's almost never true. All right, so can I still combine something here? Yes, but I only have one thing left, so I'm going to go ahead and label my answer. F of g of x is equal to negative 128x cubed minus 96x squared minus 24 plus 7. I ran out of room. See, y'all better be on it today, I'm telling you. Oof. It's not even Friday yet. We good? All right. Now let's go the other way. This is g of f of x. Ugh. So I'm going to take f of x, substitute it into g. This is going to give me 4 times 9 minus 2x cubed plus 1. So can I distribute the 4 at this point? Yes, it's different because that's on the inside. Good. So this just gives me 36 minus 8x cubed plus 1. So g of f of x is equal to negative 8x cubed plus 37. Any questions at all? Besides, why is my brain misfiring right now? Okay, let's look at 4. 4 gives me, this is f of g of x. So g goes into here, so I'm going to have the square root of x squared plus 5. So is this going to become x plus the square root of 5? No, you do not get to distribute the square root like that. That 1000% doesn't make any sense. Okay, when you have addition and subtraction, you can't just willy-nilly start doing things there. So there's literally nothing else I can do. That is my answer. F of g of x. That's it. So then when I do g of f of x, this is equal to square root of x plus 5 squared. What's the square root of x plus 5 squared? X plus 5. So this is equal to x plus 5, which is equal to g of f of x. And that's over there in the green monkeys. You can't see it really for all the calculators maybe, but square root of a monkey squared is a monkey. It doesn't matter what's underneath it. The square root of a million squared is a million. Okay, that is what it is. Yes, ma'am. Oh, just put them in. Is that blue thing empty? Well, you take them out of it and just throw them like, ew? Oh, have you been traumatized? Yeah, just take those out and lay those right there, and then you can put the ones that don't work in there. Thank you. Okay, example 5. Here we go. F of g of x. So this will be, I'm taking this and substituting it in here. So I'm going to have the cube root of x plus 4 cubed minus 1. So what's the cube root of x plus 4 cubed? X plus 4. So this is equal to x plus 4 minus 1. So f of g of x is equal to x plus 3. All right, so then g of f of x is going to be the cube root of x cubed minus 1 plus 4. All that's underneath. So I put in the parentheses because it was more than one term, but I can combine my terms underneath there. So this is the cube root of x cubed plus 3. So is this going to become x plus the cube root of 3? No, because you can't split this, just like you can't split square roots. Not like that anyway, and that is equal to g of f of x. What questions you got? Everybody good so far? All right, so again, just making sure we understand where not to make up math. Okay, be careful, ask yourself if you're making something up before you just start willy-nilly doing things. All right, so that's how we compose when we have it's all variables, right? One function into another. Now we're going to look at composition when we evaluate. So this f of g of 3 I can rewrite as f of g of 3. Now when we evaluated yesterday, I substituted in the 3 to like both of them as we added or subtracted or whatever we did, and that's fine for that. I don't think that that's really the best way to do this here. I think instead we should do it a piece at a time. You work from the inside out. So we're going to find g of 3. G of 3 is, where's g? It's just 3 plus 1, which is 4. Okay, so I got the g of 3 is 4. So now I want f of 4. And that's equal to the absolute value of negative 2 times 4, which is the absolute value of negative 8, which is 8. So f of g of 3 equals 8. Okay. What questions you got? All right, you do B. When you're done, check yourself with me. Let me know if you have any questions. And notice my answer is not 11. My answer is g of f of negative 5 equals 11. Don't just randomly have a number floating out there. What is it? You have to label your answers. Okay? What questions do you have? We good? All right. Number 7. We have f of g of 9. Okay, so I start with g of 9. So that's the square root of 9 minus 4. And let's just pause right there. For all you non-believers that don't understand why we can't split square roots when there's an addition and subtraction, if we could do what some of you want to do, this would become 3 minus 2, right? Like I take the square root. So what is 3 minus 2? 1. Okay. But when we do 9 minus 4, we get 5. The square root of 5 is not anywhere near 1. Okay? So it does not work. I promise you. I wouldn't make you go, like, I don't know why we would bother doing the rest if we could just do it easier like that. So we get the square root of 5. So then I'm going to do f of the square root of 5. That's equal to the square root of 5 squared plus 5 times the square root of 5. So the square root of 5 squared is 5, right? 5 times the square root of 5 is 5 times the square root of 5. And that is f of g of 9. Okay, we good? Don't be making up rules with, making up math with square roots. Okay, so now we're going to do g of f of 7. So f of 7 equals 7 squared plus 5 times 7. So that's 49 plus 35, which is what? 84. So then we will do g of 84. That is equal to the square root of 84 minus 4, which is the square root of 80. Is 80 a perfect square? No. Do I get to leave it like that? No. Do I put it in the calculator and get a decimal? No. Okay? Instead, you have to be able to simplify your square roots. So, there's more than one way to do it. Follow me on this way first. I get 8 times 10. You can just do the little tree. 10 is 2 times 5. They're both prime numbers, so I'm going to circle them. Okay? They're at the bottom of my branches. 8, I can make 2 and 4. 2 is a prime number, 4 is a perfect square. So I can take the square root of my perfect square, and that gives me 2. Then I have 2 2's that come out as a 2. Oh, goodness. 2. And then this 5 is by himself, so he has to stay in the house. So that means in the end that g of f of 7, 7 is equal to 4 square roots of 5. Okay? If the way you learned to simplify square roots was to always look for the largest square root, the largest perfect square that divides into that, that's not wrong, and there's nothing wrong with that, but that shouldn't be the only way you know how to do it. Because if it is, I would assume that most of you, myself included, when I see 80, the first thing that pops in my head is not, 16 divides into 80, right? Maybe it is for you, but that would be just a couple of people. Instead, we might have to guess and check to figure out if it's 16, right? So instead of guessing and checking, if we just do the tree, we're done before other people have scratch work all over the place trying to figure out what the biggest perfect square is, okay? Now, if you know what it is, like you see it and you know it, like 32. 16 goes into 32, so I can do 2 and 16. Totally fine way to do it. But you also need to understand the tree for the other numbers that you don't just naturally recognize divisors of, okay? Make sense? We good? Any questions at all? All right, we are going to leave this for tomorrow. I'm probably just going to give you a whole new sheet because I want to do something a little bit different with this and spend some more time on it. So we're going to stop here for today, which gives you lots of time to get started on your Delta Math, so make good use of your time. and get stuff done. And fold this and tape it into your ISN right now.